Well, welcome back. So what we're going to do now is we're going to take our method that we just talked about in using the standard normal distribution and interpret that in terms of something that is not a standard normal distribution. What do we do? Well, this section presents a method for working with the normal distributions that are not standard, and that is if the mean isn't 0 and the standard deviation is not 1, or both. If we do this by hand, the key concept is that we can use a simple conversion that allows us to standardize any normal distribution so that the same methods of the previous section can be used. That is, we're going to get a z-score for any x value that we're being asked about. And we always round our z-scores to 2 decimal places, and our z-score is found by taking x minus the mean divided by the standard deviation. So to go from a standard normal, non-standard normal distribution to the standard normal distribution, it's really a matter of getting these values back into terms of z, that standard score. Now in Excel, we can enter the information directly that we want to find without even having to stop for doing that. So I'm going to show you the Excel method rather than having to go through the hand method of doing this. And as an example right here, let's say that I told you that I wanted to find from a distribution where the mean was 5 and the standard deviation was 1.5, what would be my probability that x is less than 3? Well, in this case, the way I'm going to enter it, I'll show you right here in the little entry box for this cell. It's the normal distribution. We would enter 3 for x, so we enter in the x value that we're interested in, the mean of our distribution, in this case mu, the standard deviation, we had 1.5 right there, and we enter 1 for true. All right, so we get 0.09121, and what we're looking for really kind of goes like this. It says that if we have a normal distribution, and we want to find out that if the mean is 5, the standard deviation is 1.5, and we find 3 right here, what is this area? Well, we have our answer in that area has to be equivalent to 0.09121. Alright, so let's use this in an application. And this is an interesting one, that many airlines have a requirement that members of the cabin crew have a height between 62 and 73 inches. That is somewhere between 5'2" and 6.1. Any shorter than 5'2", they might not be able to reach all of the cabinets and overhead compartments that they need to. Over 73 inches, they're going to be bumping their head and be very uncomfortable. So given that men have normally distributed heights with a mean of 69.5 inches and a standard deviation of 2.4 inches within the population, let's find the percentage of men who might satisfy that requirement. Right? So in this case, we're going to be using a mean of 69.5 inches and a standard deviation of 2.5. And so in our Excel, whenever we enter in a value of x, right, we'll use our mean, 69.5 right here, and our standard deviation, of course, 1 for true. And we'll figure it out from there. All right, so what are we really after? Well, what we're really interested in is the number, is the probability of finding an individual between those two heights, 62 and 73 inches. Now, you'll recall that what that really meant for us to do is that we would have to take the probability that we're going to get in height of an individual less than 73 inches and subtract from that the probability that we're going to find somebody whose height, and that's our random variable, is less than 62 inches. And the difference between those is going to be that probability that x is between those. So again, let's go to an Excel sheet and check this out right here. So we're going to subtract our two probabilities right here, and I'm going to show you how I would enter this in. This time we're going to use norm.dist, not the s-dist, right? Just normal.s.dist. And we're going to enter 73 for our inches. We had 69.5 inches as our mean, and our standard deviation we said was 2.4 inches. Let's just make sure of the numbers right here. Right, 2.4 inches, there it is. Okay, very good. So we take that, of course we enter 1 for true. That's going to give us our probability that x is less than 73. Now let's subtract from that. Norm.dist. This time we want 62 inches, but this time with the same mean and standard deviation, so 69.5, 2.4. We choose 1 for true for our cumulative distribution. There it is, 0.92647. So 0.92647. That's our probability. 0.92647. So let's say, according to this result, what's the exact proportion of males that would fail to satisfy? Well, that's an interesting question, but, well, if 100% of males might fall into this category, then what are we going to do? Well, we're going to take 1 minus that to find the ones who don't. Right? So if we know this probability, that's a 62. This is the 73 over here. That's where the 3 goes. All right, so if we took 1 minus that, I'm just going to go to Excel because, I like doing that, equals 1 minus this value, 0.732. So we would say 0.732. Or we might say it a different way, that 7.32% of the population might not qualify for that height requirement for our airlines. Okay, one more right here. Since it is a table, very often we are able to look up things backwards. That is, if we have the probability, can we find the z-score or an x-score that goes with that? Well, absolutely we can. So some educators argue that all students are better served if they are separated into groups according to their ability. So let's assume that students are separated into groups using IQ scores, and we're going to have a group that's in the bottom 30%, a second group in the middle 40%, and a third group that is the top 30%. How should we choose our values of x to make that happen? Well, in this case, what we're going to do is we're going to have to use a little bit of a different tactic. This time we're going to have to look up a value. Now, if we're using a table, what we'd have to do is we'd have to say, for example, if I was interested in this area down here, and I'm going to call this area A, if I were interested in area A, I already know what the area is. That is my probability right here in area A is equal to 0.3. Right? So I know that area. Now let's call this area B right here, and this area C. What do I know about area B? Well, area B will be equal to 0.4. But if you remember, what we might have done in the past was we might have looked for the probability that x was between, well, we'll call them x1 down here, x1, I'll call this x2. We wanted to know that the probability between x1 and x2, whatever those scores were, we wanted to know that those were equal to 0.4. So how are we going to work this out? Well, really, what we would have done if we were working at this, and let's say I knew what x1 and x2 were, I would have taken the probability that x is less than x2 and subtracted away the probability that x is less than x1. Right? So in other words, it's as though we were saying, okay, we've got area A plus B, right? That makes up that area of everything that's less than x2. And I'm subtracting from that area A, and that's going to give me area B. All right. So the real question is, okay, well, what scores x2 and x1 make that up? Well, here's what we're going to do. In Excel, we're going to use the command norm.inv, and that's going to give us the z-score, or the z-score associated with our x-score, let's say, associated with a probability from a distribution that has that particular mean and standard deviation. So let's go through it. First, let's find the 30th percentile score. What that means, of course, is that we're trying to find our x1, right? So we're trying to find the value of x1, sometimes we call it k, such that that score is equal to 0.30. So what we're going to do is we're going to enter this in for P. 0.3. For our mean, this is the Wechsler intelligence scale using IQ score, right? So it's normally distributed with a mean of 100 and a standard deviation of 15. So we'll just go ahead and enter them as 115. I know it's going to come out representing the percentage, but in Excel, that's the way we'll handle it, right? So our 30th percentile, we're going to say equals norm.inv. Choose this function. Our probability is 0.3. That's our percentile score. The mean of this standard deviation is 100, and the standard deviation is 15. Now, if we wanted to get the z-score, we would put in 0 and 1 instead of 115. But we're interested in the exact score, so we're going to get 92.134. Well, how about that 70th percentile? Same procedure. Norm.inv, here's the function. Our probability in this case is 0.7. And our standard mean 100, standard deviation of 15, gives us a score of 107.8. Now, I happen to know that in the Wechsler intelligence scale test, right, our probability, our value of k that fits this value right here, they come out in whole numbers. So we said this was something like 92 point something. We would give 92 as the actual percentage score for which is going to happen. For our secondary score, that x was less than this value, and we'll call it K2 here, just to make it different from the first one. That was at 0.7, right? We said that our probability was equal to 0.7. So when we did that, we would find that K2 in this case was equal to, what did we say that was? 107.86, right? 107.86. But we're going to give that as 108%. Okay, so the middle 40%, well, their score is going to be somewhere between 92 and 108 on the Wechsler IQ exam. And that's the way that we would outline that. All right, Excel is a mini splendid tool that gives us the ability to find these things without having to go through too much trouble in order to do so. That's a nice thing. All right, so don't forget the assignments due this week. By Friday the 6th week, make sure that you've gone through the Chapter 6 lecture and completed the Lecture 6 form. By Monday of week 7, don't forget that the Chapter 6 WebAssign homework is due, and complete the online Quiz 3. Well, that's it, everybody. Have a great week.